Hello friends, welcome to my channel. Today we are going to see how to draw phasor diagram of single phase transformer with inductive load. To draw phasor diagram is always challenging task for an engineer. Let's see. To form a phasor diagram, a few steps. Need to understand series RL circuit, transformer basic principle, transformer circuit diagram, terms related to the secondary side and terms related to the primary side. Let's take simple RL circuit. Inductance L connected in series resistor R. I is a current fading by the voltage V. VL is a drop across pure inductance which is equal to IXL, where XL equals to 2 pi FL. VR drop across pure resistor which is equal to IR. From phasor diagram we can see VR in phase with I. From voltage diagram VR and VL vector with angle 90 degree. From impedance triangle Z can be formed with X and R. In rectangular form Z equals to R plus JXL. Z equals to square root of R square plus XL square. Okay, let's take simple transformer. N1 number of turns in primary winding, N2 number of turns in secondary winding. Primary winding fed by alternating voltage V1. Secondary side connected with inductive load ZL. Voltage across the load is V2. I1, X1 and Z1 are the resistance, reactance and impedance of the primary winding. R2, X2 and Z2 are the resistance, reactance and impedance of the secondary winding. I1 current flows the primary winding, I2 current flows in the secondary winding. Primary winding and secondary winding are magnetically connected with the flux phi. Sinusoidal flux in the core phi equals to phi m sin omega t. We can say as equation 1. According to Faraday's laws of electromagnetic induction, E equals to minus d phi m by dt. That is equal to minus d derivative of phi m sin omega t by dt equals to minus omega phi m cos omega t. That is equal to omega phi m sin omega t minus pi by 2. Sin omega t minus pi by 2 equals to 1. So Em equals to omega phi. EMF equation E equals to Em sin omega t minus phi by 2. So from equation 1 and 2 we can say that E2 lags phi by 90 degree. To form a phasor diagram we need to find these 17 terms. So start with phi. Flux phi is a common for primary as well as secondary side. E2 lags phi by 90 degree. Better understanding, we have drawn equivalent circuit of a transformer. Primary side and secondary side linked with flux phi. KVL, we apply KVL at secondary side. V2 equals to E2 minus I2 R2 minus J I2 x2. Current I2 is flowing in the secondary side. I2 R2, which is in phase with I2. To form a phasor diagram, we are showing in a reverse way. So minus I2 R2. 90 degree to this I2 R2 will be I2 X2. Resultant vector of this I2 R2 and I2 X2 will be minus I2 Z2. If we join origin to this I2 Z2, we can get V2. The angle between I2 and V2 is angle phi 2. In this way, we can form all the terms related to the secondary side. Let's focus on primary side. Okay, for the primary side, equation is V1 equals to E1 plus I1 R1 plus J I1 X1. I1 primary current consists of I0 plus I2 dash. I0 consists of Im plus Iw. Im, which is in phase with phi. Iw is 90 degree with Im. If we draw resultant of these two vectors, we can easily form I0. I2 dash is secondary current referred to the primary side, which is in parallel with I2. I2 dash is equal to Ki2. K is a transformation ratio N2 by N1. If we join I2 dash and origin, we can get I1. Next one is E1, which is opposite direction with same magnitude, so it's minus E1. I1 R1, which is in phase with I1, can be shown in parallel I1 R1. I1 X1 is 90 degree with I1 R1. Resultant of these two is I1 Z1. From this point and origin point, V1 can be formed. The angle between V1 and I1 is phi 1. So from this phasor diagram, we can get the 17 terms. The angle phi 1 and phi 2 are not same. This is a step-by-step approach to form phasor diagram. I hope you like my video. Please do like, share and subscribe. And if you have any question, please let me know. Thank you.